Good afternoon, sir. Welcome to the live virtual classes organized by the Board of Studies Academics, ICAI. Myself, Dr. N.V. Ravi, Faculty, Board of Studies. Along with me, CA Arijit Chakravarti ji, today's faculty. I would like to introduce him about CA Arijit Chakravarti. He is a commerce graduate from St. Xavier's College, Calcutta, and he is a holds chartered accountancy and an MBA Finance diploma and a diploma in Information Systems and Audit. He is a renowned faculty from the Kolkata and across the country also. Actually, his area of interest is risk management also. He has delivered many lectures in ICAI forums, and with his background, I welcome you, CA Arijit Chakrabarti sir. And today's topic is differential calculus and which is very important, and how to compute the differential equations that will be explained with the coming slides also. And this is a background about the today's section. For the examination point of view, we can expect from this chapter 3 to 4 questions are coming from this chapter. Welcome, sir. C.A. Arijit Chakrabarti, over to you.
Right. Oh, yeah. Good afternoon and thank you, sir. Good afternoon to all the students who are attending this session. So, as sir mentioned, that these are two very important chapters, differential calculus, and quite a number of questions keep coming. So, I think the slide is visible. We will move first to the coverage for today's session. So this is, I hope you have received the presentations which has been uploaded already. So here we are covering the basic applications of differential calculus. In fact, as we go forward, we will discuss that differential and integral calculus both have a lot of applications in business and economics. And in your role as a chartered accountant later, even in your intermediate and CA final, you will find a lot of practical applications of differential calculus, especially in areas like finance, economics, and of course, later on in other advanced domains as well. So we have two parts. First is differential calculus, which we are discussing today. And thereafter, on the 7th of this month, we shall take up integral calculus. So the objective of the two sessions, specifically from exam perspective, is to understand the basics of limit, differential coefficient, differential calculus, different formulas are there which we need to go through, and how to compute the derivative of different algebraic expressions. Of course, we don't have trigonometrical expressions, but mostly it will be algebraic expressions. And yes, an important part is areas like parametric equation, logarithmic differentiation, and maxima minima. So many of you have gone through already. You must be practicing the questions and you must have gone through the chapter. So let us dive deep into the area. Today, of course, is differential calculus, where we are going to look at some of the basic laws of differentiation, and there will be some standard results which you definitely need to keep in mind. And of course, another important area is the applications. So we shall be dividing the session into different parts. First being the basic laws of differentiation, and then we go to the standard results, and thereafter the applications. Okay, so what is differentiation? So differentiation is a very important fundamental operation of calculus. And here the idea is you already have gone through the concept of functions, discrete functions specifically, and continuous functions. So the idea here is on the central concept of limit and continuity. So differential coefficient dy by dx, as we call it or as we put it, reflects the rate of change in any function with respect to a derivative involving a small change in the dependent variable with reference to a very small change in the independent variable. So as we know, y equal to fx, y is a function of x. So here x is the independent variable, whereas y, the value of y depends on x. So if I say that, say for example, y is equal to say ax squared plus b. So here ax squared plus b, so here x is the independent variable, whereas y is the dependent variable. So the differential coefficient is actually measuring the change, the quantum of change in y, which is the dependent variable, for a very small change in the value of x. So that is the reason why you should be clear with which one is independent variable and which one is the dependent variable. Therefore, differentiation is also known as finding the derivative of a continuous function. So the function has to be continuous, and only then we shall be able to find out the derivative or the differential coefficient. And you can see in the slide, in the lower part of the slide, that fx and f dot x. So differential coefficient is denoted by f dot x. And this is with respect to the change in, as we call it in the language of calculus, infinitesimally small, very small change in the value of y for a corresponding change in the value of x, where x is the independent variable and y is the dependent variable. So derivatives, we will do number of practical questions, both from the study material. I will also try to complete several questions, solve several questions from the mock test paper, MTP, the revisional test paper, and a few questions from past year's exams. And as Ravi sir mentioned, that we have quite a number of around 3-4 questions keep coming from this particular chapter. And one of the questions which is coming almost in every exam is the derivative in the nature of a tangent. So we will go into that. Derivatives measure the pitch of a line. So it measures the tangent, especially when the tangent meets a particular curve. So derivatives is also defined as the slope, and the independent variable, that is x, is denoted by the input variable, whereas the dependent variable is the y. So as we call it, y equal to fx. Y is a function of x. Okay. Now let me first go to the part 8a. If you look at our study material 8a2. So there, the small increment in x and the corresponding increment in y. So this dy, if you see, is a very small change in the value of y. And as this difference tends towards 0, that means here we come to the question of limit. So y equal to fx is a function, and there is a very small difference, let us call it delta x, a small increment in the value of x. The corresponding increment in y, and this particular limit, that is limit delta x tends to 0, function x plus delta x minus function of x divided by delta x. This is the differential coefficient denoted by dy by dx. And sometimes, as we were saying, this is also the derivative. So the derivative of fx is known as the differential coefficient with respect to x. And this is absolutely the first principle of differential calculus, where we find that the limit of delta x, the difference, the small difference, is tending towards 0. So you can see that in this equation, in this particular expression, delta x is not equal to 0, but it tends towards 0. That means it is becoming smaller and smaller, a very small change. So differential coefficient measures the rate of change in the dependent variable with respect to a very small change in the independent variable. This is the basic concept. And differential coefficient like df by dt, you can see here that here we have a function ft, and a very small change in the function occurs when there is a small difference h. So the difference becomes function t plus h minus function t divided by the difference h, and the h, the small difference, is tending towards 0. So this ratio is the differential coefficient. It is also denoted as f slash or f dot x. So f dot x is dy by dx. This is when the delta x tends towards 0 and we try to find out the difference, the infinitesimally small difference in the value of the dependent variable y for a corresponding change, very small change in the value of x. So delta x is tending towards 0, but it is not equal to 0. So this is the limit concept in differential calculus. Now let us see a small example, f dot 3. So here 3 plus h whole square. So the original function, say for example, we are taking f3. But now if there is a small change h, f3 plus h whole square minus 3 square. So if you see the formula, we can see that the value as h tends to 0, the value comes to 6. So this is one example. The other example is fx equal to 4x cube. So what will be the differential coefficient? So 4x cube. If there is a small change in the value of x, say x becomes x plus h, where h is tending towards 0. So now instead of 4x cube, we are putting 4 into x plus h whole cube minus 4x cube divided by h. So we are finding out the original function and the difference between the function which is changing due to the input, due to the fact that h is now included. A small change has happened in the value in the independent variable, and we are trying to find out the corresponding impact in the dependent variable, and accordingly the answer comes to 12x squared. And this is absolutely as per the fundamental principle.
Sir, this
Yes,
one
sir.
is a example. F of x equal to first one is x square.
Yes, sir.
Yeah.
Plus h whole cube minus 4x cube. Yes.
Yes.
Two of the examples. Yes. Okay. Now we look at some of the basic functions, and most of the questions in the exam, if you see, are you'll be able to definitely answer all the questions correctly if you remember some of the important formula. So looking at our syllabus for differential calculus, we have around 8 to 10 very simple formula which you can easily remember. And the basic example is differential coefficient of x to the power n. So the differential coefficient of x to the power n is nx to the power n minus 1. So if I ask you that what is the differential coefficient of x to the power 4, x to the power 4, so it will be 4x to the power 4 minus 1, that is 4x cube. Similarly, if you take the following examples on the slide, y equal to 4x. So the differential coefficient here we can see is 4x to the power 1 minus 0. 1 minus 1, sorry, that is 0. And we know that any expression to the power 0 is 1. So x to the power 0 is 1, therefore 4x, when we differentiate 4x with respect to x, the answer is 4. 4x square. So here the power of x is 2. If you look at the index number here, in the index, it is x square. So therefore, when we are finding the differential coefficient of 4x square, it becomes, the formula is n into x to the power n minus 1. So 4 into 2 into x to the power 2 minus 1, that is 8x. In this way, the formula is valid for all types of powers. It can be negative. For example, in the third example, we have 4x to the power minus 2. That means this is basically 4 divided by x square. So we have x to the power minus 2. So the same formula, nx to the power n minus 1. So here n is minus 2. So we have 4 into minus 2 to the power x and multiplied by, of course, x to the power n minus 1, where in this example it becomes minus 2 minus 1, that is minus 3. So we will take some more examples. ddx of x is always equal to 1. And please remember that differential coefficient of a constant, say we are taking c is a constant, ddx of c is equal to 0. So the basic formula we are taking is, please remember that x to the power n differential coefficient is nx to the power n minus 1. And the differential coefficient of any constant is always equal to 0. Some more examples we will take. Now we have a Euler's constant. You will find these questions coming frequently in the exam. E to the power x. Now E is a constant, like all of you know pi. Pi, like while you calculate the circumference of a circle, you know we have the formula, the circumference equal to 2 pi r. So pi has a value of 22/7 approximately. Similarly, if you look at the E is Euler's constant. The value of E is around 2.718, and this is also known as an exponential constant. Now the differential coefficient of e to the power x will remain e to the power x. So d dx of e to the power x will be equal to e to the power x. When we have another function of x, say for example a to the power x, where a is a constant, a to the power x. So here the differential coefficient is a to the power x multiplied by log a to the base e. So these are all fundamental formula which are mentioned in the study material, which you need to memorize, because in the case of our exams, most of the questions are fairly easy to moderate, but we need to memorize these formula so that we are able to quickly apply and able to solve the problems within the given time. Similarly for log x, so logarithms you already covered earlier. So differential coefficient of log x, that is if y equal to log x, then dy by dx is 1 by x. So these are formula which we need to remember. 8A3 from the study material which you see on this slide captures all the formula which I was discussing till now. So you have the first one, x to the power n. So differential coefficient of x to the power n is n into x to the power n minus 1. The second one is with regard to the Euler's constant, that is e to the power x. So as I was discussing, Euler's constant is around 2.718, the value, and e to the power x, once you differentiate, the value remains same, e to the power x. A to the power x, where a is a constant. So here the differential coefficient is a to the power x log a to the base e. Fourth one, the differential coefficient of a constant will always be equal to 0. The fifth is d dx, that is differential coefficient of e to the power ax. So here the differential coefficient is a into e to the power ax. The last one is the differential coefficient of log x, which is very simple, 1 by x. So these are very simple formula, and the applications, we will see number of applications, exam type questions, which ultimately requires everyone to remember the formula. So once we remember these standard results, the basic formula, we are able to handle any type of question as per our curriculum. Now the next is when you have something like, say, functions where we have a scalar multiple. Say for example, we have a particular function y equal to 8x square. So this means y equal to 8x square. So 8 is a multiple. So this 8, if you see on the right hand side, this 8 is like a constant, so it will remain outside the differential. So what we will do is d dx of 8x square actually means 8 multiplied by d dx of x square. So ultimately it becomes 16x. Similarly, when there is a sum or difference of a function, there are two functions. Say we have fx plus gx. Both are functions of x. So now if we are to find out the differential coefficient of fx plus gx, we will just find out their differential coefficients separately. So d dx of fx plus gx or d dx of fx minus gx, is simply equal to d dx of fx plus minus d dx of gx. So these are the three, four formula which we see on this slide. The next one is the product function. So when we have a product of two functions, say fx multiplied by gx, we have to find the differential coefficient of fx multiplied by gx. So here what do? First, we take, say for example, fx and gx. So first we keep fx, multiply this fx by the differential coefficient of gx, and then we add. This is the first part. The second part, we keep gx, and then what we do is we multiply fx, we differentiate fx. So the formula becomes fx into d dx of gx plus minus gx, sorry, plus gx into d dx of fx. So two functions, fx and gx, we are taking up. First we keep fx, multiply it by the differential coefficient of gx, plus we take gx and then we multiply it by the differential coefficient of fx. And finally, we have the quotient rule. So we will take some examples and then we will see. The first example here is y equal to 2x squared plus 3x. So in this case, we are first we are carrying out the differential coefficient calculation. The function is y equal to 2x squared plus 3x. There are two functions, 2x squared and 3x. So we will just find out the differential coefficient separately. First 2x squared. 2x squared differential coefficient comes out to 4x, and 3x, the differential coefficient comes out to 3. Because 3x means 3 into x, and we know the differential coefficient of x is 1. And therefore, the differential coefficient of 2x squared plus 3x comes out to 4x plus 3. Similarly, the second example, y equal to 5x plus 4. So dy by dx is simply equal to 5, because 5x, 5 into x, we know differential coefficient of x is 1. So 5x differential coefficient is 5 into 1, that is 5. And then we have 4, but we know 4 is a constant, and the differential coefficient of a constant is 0. So dy by dx, where y equal to 5x plus 4, ultimately boils down to the answer 5. dy by dx equal to 5. The next example, fx equal to 7. So please see that this number 7, it is a constant number. So what will be the differential coefficient? F dot x, it is equal to 0. Next question, y equal to minus 3. Now minus 3, this is also a constant number. So f dot y, or dy by dx, whatever you call it, comes to 0 because it's a constant number. Next question, fx equal to x cube. Fx is equal to x cube. So this is the basic formula, x to the power n, and the differential coefficient is n into x to the power n minus 1. So here x, the formula, the given expression is, the function is y equal to fx equal to x cube. So here n is 3 because we have x cube, x to the power 3. So if you break it down, the formula is, the differential coefficient is n into x into to the power n minus 1. N into x to the power n minus 1. That means here n is 3. So the differential coefficient becomes 3 into x to the power 3 minus 1. So this becomes, answer is 3x squared. Next example, y equal to x to the power 9. Y equal to x to the power 9. Y equal to x to the power 9. So here n is equal to 9. The formula, the basic formula, fundamental principle, x to the power n. Differential coefficient is n into x to the power n minus 1. Here n is 9. So the differential coefficient will be 9 into x to the power 9 minus 1. So I hope you're able to follow. These are simple and introductory formula in differential calculus, and this chapter is highly scoring because if you review the type of questions coming from this particular chapter, as Ravi sir was intimating, I was informing all of you so that you are better equipped to face the exam. So the questions are fairly easy and you have entire chance, you have a high chance of solving them because the questions are based on the fundamental formula which we are covering one by one. So for y equal to x to the power 9, where n is equal to 9, so the differential coefficient will be n into x to the power n minus 1. That is 9 into x to the power 9 minus 1. So the answer becomes 9 into x to the power 8. As you can see, dy by dx equal to 9 into x to the power 8. The next example we are taking gx, a function of x, gx. What is the function? X to the power 100. X to the power 100. Simple formula, x to the power n, here n equal to 100. So the formula is differential coefficient will be g dot x or g slash x. That is the differential coefficient is equal to 100 into x to the power 100 minus 1, because the formula is n into x to the power n minus 1. So the differential coefficient is 100 into x to the power 100 minus 1. That is 100 into x to the power 99. Please note that what we are discussing right now in differential calculus, on the next day we will do the reverse, because there when you have to do the integration, the formula will just become reverse. So these are very interrelated formula, and once you understand differential calculus and you are able to solve the problems, integral calculus becomes easier because all these principles and formula are related to each other. And as we can understand slowly, differentiation is the opposite of integration. Similarly, integration is the opposite of differentiation. In differentiation, we are breaking down. In integration, we are going to bring them together. We are going to unite them, integrate as we can call it.
Well
The
explained, sir. Well
next,
explained.
yeah, thank you, sir.
Very
Now
good.
we have the next example. So slowly we are taking a little, difficult sums. Y is equal to 2x to the power 1 by 3. So the formula we know is x to the power n. Differential coefficient is n into x to the power n minus 1. Here we have a constant 2. Then we have 2 into x and x as a power, which is 1 by 3. So what we do here, as we know, 2 will be constant as usual. So when you find out dy by dx, 2 we will write first, and then we will use the formula nx to the power n minus 1. Here n is 1 by 3. So therefore 2 into 1 by 3 into x. And now we have to find out the new power of x. The new power of x will become n minus 1. Here n is 1/3. So the new power will become 1/3 minus 1. So accordingly, first we write 2. As you can see, the 2 constant remains same. And then x, the power of x is originally 1 by 3. So we write 1 by 3 first. Then we write x, and then in the new power becomes 1 by 3 minus 1. Because the formula is nx to the power n minus 1. So the new power of x becomes 1/3 minus 1, that is minus 2 by 3. So this is a little different from the earlier one. And therefore, if you rearrange this particular expression, what you get is 2/3, 2 by 3 into x to the power minus 2 by 3. Or you can put x from the numerator to the denominator, in which case the power will also change. From minus 2 by 3, it becomes 2 by 3. Next example, derivative of 4x squared by 5. So the function fx is given 4x squared by 5. We have to find out the differential coefficient. Please note 4x squared by 5 we have already a constant. 4 by 5 is a constant. So we are bringing out 4 by 5 and showing it now, writing it as 4 by 5 x square. 4 by 5 is a constant, we will keep it separate. Basically, the function now becomes x square. Here n is equal to 2. We know the differential coefficient of x to the power n is how much? Nx to the power n minus 1. So x square, the differential coefficient will become 2 into x to the power 2 minus 1. So it reduces to 2x to the power 1, that is 2x. But we also have 4 by 5. So the formula, the new expression becomes, the differential coefficient becomes 4 by 5, which is a constant. It is kept outside the bracket. X square's differential coefficient is 2x, and therefore the expression becomes 8x by 5. Right? So I hope you are able to follow, and these are simple problems you can do along with the explanation which I'm giving you. Now the next one is 5x to the power 7. Next question is 5x to the power 7. So here the constant is 5. So we will bring out 5 separately. You are left with x to the power 7. This is of the form x to the power n. N is equal to 7. We know the differential coefficient of x to the power n is n into x to the power n minus 1. So if we see, this becomes 5 into 7 into x to the power 7 minus 1. So it becomes 5 into 7 into x to the power 6. 5 into 7 is 35. So we get 35 into x to the power 6. Next question, here we draw a table. We have a function, we will rewrite, we will differentiate, and then we shall be simplifying also. So the first one we see is function of x, fx is 5 divided by 2x cube. So when you get these type of expressions in the exam, because we will do number of questions today from the study material, from the revisional test paper, kindly go through and solve the questions from the RTP for the May 2026 exams. Kindly download the question papers, mock test paper, series 1, 2, and further series from the ICAI website, and kindly solve the problems. The more problems you solve, and of course, you need to check your answers, you need to check the accuracy. So the more practice you do, mathematics becomes easier for you, and your chances of scoring higher marks becomes more and more. So in this example, fx is 5 divided by 2x cube. So we rewrite it as 5 by 2. Now x cube is in the denominator. So once we transfer it in the numerator, it becomes x to the power minus 3. Right? So this is easy. I hope you are able to follow. Now we shall differentiate. Now differentiating, here we have 5 by 2. So 5 by 2 remains the same. But here we have x to the power minus 3. The formula is x to the power n equal to n into x to the power n minus 1. Here n is minus 3. First we write within the bracket, you can see first we have written minus 3. Multiply that by x, and the new power of x becomes minus 3 minus 1. The formula is n minus 1. Here n is minus 3. So n minus 1 becomes minus 3 minus 1, that is minus 4. On simplification, therefore, this becomes minus 15 by 2 to the power 2 into x to the power 4. So this is a change. This is a small difference between the last few questions, where we see we have a constant number, in this case 5 by 2, and we have a power, or when we talk about the indices, you have studied about indices and the index of x. So x is in the denominator having index of 3, but the moment we transfer it to the numerator, it becomes x to the power minus 3, and accordingly thereafter we apply the same formula. The next one is gx, a function of x, and this is equal to 7 divided by 3x to the power minus 2. So what shall we do here? As per what we did previously, we'll do the same. And what we will do now is first 7 by 3 goes out. X is in the denominator with an index of -2. So once we transfer it to the numerator, it becomes x squared. The sign changes, right? So you know that whenever we are changing a particular expression, we are removing the expression or from numerator to denominator and vice versa. The power, the index number which you have, the index will change. Now in this case, 7 by 3 x square, so we keep 7 by 3 outside and we are differentiating x square using the same principle x to the power n. X square's differential coefficient is 2x. Therefore, on simplification, we get 7 by 3 into 2x, that is 14 by 3 into x. Okay, the next one. Okay, square root. So we are taking another function where hx is equal to square root of x. Square root means what? What is the index of x? Square root means x to the power half. Square root means x to the power half. So instead of writing square root of x, we are rewriting in the next column hx is equal to x to the power half. Now it is easy for us to differentiate because now x to the power half is in the form of x to the power n. And we know the formula. We are aware about the formula. X to the power n, differential coefficient is n into x to the power n minus 1. So here n is nothing but half. So I will write for the differential coefficient of x to the power half, this is equal to half into x to the power half minus 1. So therefore, once we differentiate half into x to the power half minus 1. Now half minus 1 becomes minus half. So the final answer is 1 by 2 x to the power half. So in this way, we are simplifying. First we rewrite, then we differentiate, and finally we are able to simplify each of the algebraic expressions we are given. Now we take Jx. This looks critical, this complicated. Okay, we have 1 by 2, and then we take the cube root of x square. Okay, so this might look little unnerving in the beginning, but there is nothing to be afraid of because we will do it in a systematic and in a structured manner. First, we rewrite. Sometimes the expressions could look a bit daunting, but we will just rewrite it like this. So what we do is cube root of x square actually means already you have completed in the law of indices, you know. So therefore, using the principles of indices, cube root of x square actually means x to the power 2 by 3. But now we have to bring this x to the power 2 by 3 is currently in the denominator. I need to bring it in the numerator so that I can apply the formula of x to the power n, which is a fundamental formula. We are using the formula to solve all these problems. So what we do, we will keep half aside as it is. Now x to the power 2 by 3 in the denominator, we will move it to the numerator. Automatically the sign changes. The index, which was originally 2 by 3, now becomes minus 2 by 3 because we have moved x from the denominator to the numerator. As a result, it is easy for us to differentiate. We can apply differentiation principles, differential calculus, and we are getting the differential coefficient. Half is a constant, half remains as it is. The formula is x to the power n. Differential coefficient is n into x to the power n minus 1. Here n becomes minus 2 by 3. Please observe n here is minus 2 by 3. So what will be the differential coefficient of x to the power minus 2 by 3? N is minus 2 by 3. So let us write first n. That is minus 2 by 3 into x to the power n minus 1. N is minus 2 by 3. So minus 2 by 3 minus 1. So this will become x to the power minus 5 by 3. Now once we simplify, you can see 2 and 2 cancels out. So we are left with the answer minus 1 by 3. And what you see, x to the power minus 3, we are bringing it back to the denominator, and it becomes 1 divided by 3 into x to the power 5 by 3. So in this way, we can complete many of the problems. The next one we have is ddx of 3x square minus 2x plus 1. 3x square is now simple. It is just equal to 6x. Because 3 is moving out, 3 is a constant. We are left with x squared. Differential coefficient of x squared is 2x. So you have 3 into 2x. Then you have ddx of 2x. That is the differential coefficient of 2x. Differential coefficient of 2x is 2. And last we have 1. But we know 1 is a constant, and ddx, that is differential coefficient of a constant, is 0. So we are left with the expression 6x minus 2. So this is the differential coefficient of the given expression 3x squared minus 2x plus. Okay. Square becomes, the differential coefficient becomes 5 into x to the power 2. So the formula is n into x to the power n minus 1. So it will be 5 into 2 into x to the power 2 minus 1. Basically, it simplifies to 10x. Then you have 7x plus 7x. 7x differential coefficient will be simply 7. Because x, we have x means x to the power 1. So ultimately, when we differentiate x, it becomes 1 into x to the power 1 minus 1. So therefore, we only get 5x squared, that is 10x plus 7. The differential coefficient of 6 minus 6 is 0 because we know it is a constant. So we are getting 10x plus 7. The next one is a longer one, 4x to the power 6 minus 3x to the power 5 minus 10x squared plus 5x plus 16. If you are there with us, kindly try to solve this. So this I am also solving line by line. First, we will take using the simple formula of differential coefficient, which is the sum and difference rules. So here we have both sum and difference. 4x to the power 6 minus 3x to the power 5. We have difference. Again, we have minus 10x squared, difference. Then we have two sums, plus 5x plus 16. The rule simply says that when you have a long expression which comprises of sum and difference, that is plus and minus, just differentiate each of the expressions separately, but we have to keep in view the in between we have different signs. We have to keep the signs unchanged. So first we will do the differentiation of 4 into x to the power 6. So this will be 4 into 6 into x to the power 6 minus 1, that is 5. So this becomes 24x to the power 5. The next one is minus 3x to the power 5. So this will become minus 3 into 5 into x to the power 5 minus 1. Because the formula, please remember, is x to the power n, differential coefficient is n into x to the power n minus 1. So 3x to the power 5 ultimately breaks down into minus, we have 3 of course, 3 into 5 into x to the power 5 minus 1. So this will become 3 into 5, that is 15 to the power x to the, of course, 15 into x to the power 4. Next we have minus 10x squared. So minus 10x squared, minus 10 remains as it is, x square's differential coefficient is 2x. Next expression is plus 5x. Differential coefficient of plus 5x is only plus 5. And finally 16. But 16 is a constant. It's a pure number. We don't have any x expression here. So therefore the differential coefficient of 16 is 0. So the answer to this will be 24x to the power 5 minus 15 into x to the power 4 minus 10 into 2x, that is 20x plus 5. So we broke it down into parts to show you how we deal with the differential coefficient of an expression which comprises of sum and differences of different individual terms. So here we had 1, 2, 3, 4, 5. 5 terms are there, out of which one term, that is the last one, is a constant. So we were dealing basically with 4 terms, and we used the fundamental equation, the formula, differential coefficient of x to the power n, which is equal to n into x to the power n minus 1. Now we move to page 8.6 from the study material, and we see review few of the questions. So here we can see the first one is 3x squared plus 5x minus 2. So you can see the working out. Just if possible, you can just keep your pen and paper ready, and you can solve along with you can solve along with our analysis. So 3x squared becomes 6x, 5x differential coefficient is 5. So the answer is 6x plus 5. The next example from the study material is a to the power x plus x to the power a plus a to the power a. Here also we just break it down. So first we'll find out the differential coefficient of a to the power x, I'm moving my cursor, then d dx of x to the power a, and finally d dx of a to the power a. But a to the power a is a constant, so its differential coefficient will be 0. The third one, 1/3 fx equal to 1 by 3x cube minus 5x squared plus 6x minus 2 log x plus 3. Using the formula of addition and difference, what we do is first we take up the differential coefficient of each of these given terms separately. So what we do is x cubed by 3. Then you have, so x cubed by 3, but we have 1/3 also. So 1/3 into x cubed, this boils down to what? If you break it down and if you do the differential coefficient, you first write 1 by 3, and then you have x cubed. So you can write 3x squared. Minus, you have 5x squared. So you write 5, you are left with x squared. Differential coefficient of x squared is 2x. So I will write 2x. Plus 6x. What will be the differential coefficient of plus 6x? Now plus 6x, it will just be plus 6. Then you are left with the next expression, minus 2 log x. So first I will write minus 2, but then what I will do is, we know the differential coefficient of log x is 1 by x. It's a fundamental question which we have discussed earlier. Fundamental formula, d dx of log x is equal to 1 by x. Next, we have plus 3. Differential coefficient of a constant is 0. So let me first complete these questions, these solutions, these illustrations and examples, and then we will check the questions. We have number of questions which we will do. Okay. The next paragraph, we go to the product rule now. Product rule, we will take some examples. The fundamental concept is very clear and easy to understand. We have two functions, fx into gx. Up till now, we were dealing with functions where we had additions and subtractions. So the fundamental operations we know is addition, subtraction, multiplication, and division. Addition and subtraction we have done. So whenever we have an expression which contains individual terms which are added and deducted, plus and minus, we will just find out the differential coefficient of each of the terms and keep the sign, positive sign and negative sign, as it is. In case of the product rule, we have fx and gx are two functions, and we have a product. So fx into gx. So what do we do here? First, we keep fx as it is. We differentiate gx first. So the differential coefficient of fx gx has two parts. First part, fx into differential coefficient of gx. Now we come to the second part. In the second part, we keep gx as it is, and then we find out the differential coefficient of fx. So you can see the answer becomes fx into differential coefficient of gx plus gx into the differential coefficient of fx. Okay. So I'll just explain a little bit in Hindi. So अभी तक हम लोग जो देख रहे थे कि डिफरेंशियल कोएफिशिएंट जब हम लोग निकालेंगे उसका बेसिक जो 4 तरह का ऑपरेशन हो सकता है, एडिशन, सब्ट्रैक्शन, मल्टीप्लाई करना और डिवीजन. पॉजिटिव यानी एडिशंस एंड सब्ट्रैक्शंस वो एकदम सिंपली जैसा टर्म रहेगा. सो लाइक 6x स्क्वायर प्लस 5x माइनस 7. सो इसमें हम लोग इंडिविजुअली जो है 6x स्क्वायर का पहले हम लोग डिफरेंशियल कोएफिशिएंट निकालेंगे, उसके साथ 5x है, 5x का डिफरेंशियल कोएफिशिएंट हम लोग जोड़ देंगे and we will maintain the same sign, positive, negative, wherever given and however it's given in the question. जहां तक सवाल है प्रोडक्ट यानी मल्टीप्लीकेशन, दो फंक्शन का मल्टीप्लीकेशन. यहां पे fx है फर्स्ट फंक्शन, gx है दूसरा फंक्शन. हम लोग क्या करेंगे, सबसे पहले fx को अनचेंज्ड, उसको छुएंगे नहीं, उसको एकदम एज इट इज रख देंगे. gx का पहले डिफरेंशियल कोएफिशिएंट निकालेंगे. सो ये हो गया आपका फर्स्ट पार्ट, fx into differential coefficient of gx. इसके बाद एक प्लस साइन ऐड करने के बाद सेकेंड पार्ट विल बी, इस बार gx को हम लोग अनचेंज रखेंगे और fx का हम लोग डिफरेंशियल कोएफिशिएंट निकालेंगे. सो दिस इज द नेक्स्ट पार्ट. नाउ वी विल सी a few example to illustrate the multiplication, that is product rule. एक यहां पे we have taken an example from the study material. y is equal to e to the power x into log x. So इस स्लाइड के अगर राइट हैंड साइड में आप देखें, so y equal to e to the power x into log x. So what we do, there are two functions. E to the power x is the first function and the second function is log x. We know, we have already covered that the differential coefficient of e to the power x is e to the power x, whereas the differential coefficient of log x we know is 1 by x. This we have discussed earlier, and this is a basic standard formula which I'm sure all of you remember. You have gone through the chapter, I'm sure at least you have studied 1 or 2 times, I'm sure. So accordingly, going by the basic standard formula, we have ddx of ex is ex, ddx of log x is 1 by x. But the problem here is we have a product of these two separate functions. So what we do, first we keep the first function outside. Ex we are not touching. We are doing the differentiation of log x, which is the second function. So please see ex, e to the power x of course, into ddx of log x. This is the first part of the answer. Plus the second part of the answer is, now we are keeping log x unchanged and we are differentiating the first function. So the expression of a product differentiation becomes function 1 into differential coefficient of function 2 plus function 2 into the differential coefficient of function 1, right? So that means out of two functions, when we have two functions for a product, of course we are dealing only with two functions. There can be multiple functions, but we are restricting our discussion according to the syllabus of our exam to two functions. So accordingly, in this case, e to the power x into log x, we are first taking the first function e to the power x unchanged. As if it is a constant, we are keeping it outside. We are first finding out the differential coefficient of log x. Log x का differential coefficient क्या है, हम लोग को पता है, we have already gone through it, is 1 by x. So the first part becomes e to the power x into 1 by x. First part is done. Now the second part, इस बार log x जो कि second function है, उसको हम लोग unchanged रखेंगे और अभी क्या करेंगे, ex जो कि first function है, e to the power x जो हमारा फर्स्ट फंक्शन है, उसका डिफरेंशियल कोएफिशिएंट वी आर कैलकुलेटिंग. Accordingly, if you see, the expression becomes e to the power x into 1 by x plus log x remains as it is. ddx of e to the power x is e to the power x. So the expression becomes e to the power x by x plus log x into e to the power x. उसको सिंप्लीफाई करने से आपका dy by dx यानी डिफरेंशियल कोएफिशिएंट आ गया है. It becomes, if you take common, e to the power x divided by x, if you take common, you are getting 1 plus x log x. So these are typical type of problems which you could be facing in the exam. अभी हम लोग थोड़ा और एग्जांपल्स, प्रैक्टिकल एग्जांपल्स हम लोग कंटिन्यू कर रहे हैं. सो वी हैव अ क्वेश्चन, product formula x plus 2 into ax square plus bx. So here also what we have done, first we are taking the first function x plus 2 outside. We are not dealing with x plus 2. We are keeping it unchanged. Ax square plus bx, we are finding out the differential coefficient of this ax square plus bx. What will be the differential coefficient? Ax square, it will be a into 2x, yani 2ax plus b. First part is done. Now we go to the next part. What to do here? Now we will keep the second function unchanged. That is ax square plus bx is unchanged. And we are actually differentiating the first function, x plus 2. x plus 2 का अगर differentiate किया जाए, क्या होगा आंसर? x plus 2 का differential coefficient will be 1. Because ddx of x plus 2 is ddx of x plus ddx of 2. ddx of x is 1 and ddx of 2 is 0. So ultimately ddx of x plus 2 is 1. Accordingly, the answer comes out. Next question, y is equal to 4x cube minus 3x plus 2. ये है पहला function. Second function is 2x square plus 4x. So here we have done the same approach has been adopted. First जो function है, function number 1, उसको हमेशा टच मत करिए, उसको अलग रखिए. So हम लोग what we have done, 4x cube minus 3x plus 2 kept outside. First we have done the differential coefficient of second function, जो कि 2x square plus 4x. इसका differential coefficient अगर हम लोग निकालेंगे, what will be the differential coefficient? 2x square का differential coefficient is 4x. Second जो 4x है, ये जो plus 4x है, इसका coefficient आएगा 4. यानी 2x square plus 4x, the differential coefficient comes to 4x plus 4, which we have written here. Please see, first expression का last part, 4x plus 4. I am trying to move my cursor here. Now we come to, we write the plus sign, because product formula means दो expression जो होगा उसके बीच एक addition sign रहेगा. There has to be a plus sign. अभी हम लोग क्या करेंगे? We will keep the second function unchanged. So 2x square plus 4x is kept unchanged. And we will now find out the differential coefficient of the first function. First function अपना क्या है? 4x cube minus 3x plus 2. 4x cube minus 3x plus 2 का अगर differential coefficient निकाला जाए, please see that it is an application of addition and subtraction. So पहले हम लोग 4x cube का निकालेंगे, जो कि आपका आएगा 12x square minus 3x. 3x का differential coefficient is 3. So therefore, the answer comes to 12x cube x square minus 3. And in this way, this product, the product of two separate functions, we have been able to differentiate. Next is fx equal to 3x square minus 1 multiplied by x square plus 5x plus 2. इसको भी अगर देखा जाए, similar approach if you follow, same thing. पहले हम लोग, if you see the solution, 3x square plus minus 1 we are not touching, we are keeping it outside. X square plus 5x plus 2, the second function, we are differentiating this function first. X square plus 5x plus 2, the differential coefficient comes to 2x plus 5. And you can easily follow now because we have discussed the fundamental principles and the basic standard formula. Now we come to the second part. उसके बीच हमने एक plus sign. This plus sign, please don't forget. Product rule means there will be a plus sign. After this, what we are doing now, we are keeping the second function constant. So x square plus 5x plus 2 we are keeping, we are not touching it. We are not doing any mathematical treatment with this. What we are doing now is we are differentiating the first function. So here we have the first function 3x square minus 1. Differential coefficient of 3x square minus 1 comes down to 6x. So in this way, we are then simplifying and getting the answer. Okay. Similarly, other problems also similar type, like you can solve these problems. Fx is equal to 2 to the power x into x to the power 5. I have illustrated one problem here, and there are some other problems like function of x, fx equal to x square minus 1 into x plus 5. So you can try these numericals as well, so that your speed and your accuracy both will see a marked improvement. Okay, now we come to the quotient rule. In the quotient rule, so we have already covered plus, addition, subtraction. Product rule we have discussed in detail. Now we are moving to the last one, that is quotient. So this is a situation where you have a function, say hx is a function, hx is equal to fx divided by gx. So you have a function where there is a numerator and denominator. So y equal to u divided by v, where u is a function of x and v is also a function of x. In this case, the formula to be followed is this. So u and v, two functions, u divided by v, that is the given problem. So we are finding out d dx of u by v. So what we do here, the first function is u, second function is v. Like the previous solution, for the product rule, we did the same. If you go back to the product rule, we did the same. First, we were keeping, if you see, first what we were trying to do is we were keeping the first function as it is, and we were differentiating the second function. Same principle here. First function is u and the second function is v. So हम लोग क्या कर रहे हैं, पहले second function जो है उसको v we are keeping it as it is. First we are differentiating u. So the formula is du by dx. The form is du by dx. लेकिन इस बार याद रखना friends कि instead of plus sign we have a minus sign. For the quotient rule, in the numerator we have a minus sign. In the product rule we had a plus sign. In the quotient rule we have a negative sign, a minus sign. So v is the second function. It is multiplied by du by dx minus, अभी हम लोग क्या करेंगे, फर्स्ट फंक्शन u को कांस्टेंट रखेंगे और सेकंड फंक्शन यानी v को हम लोग डिफरेंशिएट करेंगे. सो इट बिकम्स dv by dx और इस बार न्यूमरेटर में आ जाएगा v स्क्वायर, यानी जो सेकंड फंक्शन था उसका स्क्वायर आएगा. सो प्लीज रिमेंबर, फर्स्ट सी द फॉर्मूला, try to remember, then do a number of problems. As and when you solve the problems, first I would always say that first few problems you can solve by looking at the formula. Okay, I will look at the formula, understand, apply in my mind, step by step I will solve it. After a couple of problem solving, I'm sure you will be reaching a stage where you will now be able to capture the formula in your mind. So now you don't need to look at the formula. You can solve it just by virtue of your memory and your processing power. So first let us see simple example. Let me go to this one. Once again, we see if y is equal to u by v. If y is equal to u by v, where what is y? Y is a function, composite function. What is u? U is the first function. U is a function of x. V is the second function. Okay, so v is the second function. Perfect. So dy by dx, the formula is, first we differentiate function 1, keeping function 2 as it is. So v into du by dx minus, please remember product rule, we have a plus sign. In case of the quotient rule, that is division rule, we have a minus sign. So now after the minus sign, what we do is we now keep the first function unchanged and we differentiate the second function. Finally, please don't forget, remember that in the denominator, we will have v square. First example, simple case, y equal to x plus 2 divided by x plus 4. That means here we have the first function is x plus 2, yani u, or second function is actually yani v, this is equal to x plus 4. So what is the logic? First, we are keeping second function as it is. X plus 4 is kept unchanged. First, we are differentiating function 1, yani x plus 2. So x plus 4 is kept unchanged. If you see, I'm moving the cursor, x plus 4 is kept unchanged. First, we are differentiating x plus 2. इसका differential coefficient comes to 1. क्योंकि ddx of x plus 2 is 1. एक माइनस साइन हम लोग लगाएंगे. उसके बाद अभी क्या करेंगे, फर्स्ट फंक्शन को अनचेंज रखेंगे, x प्लस 2 इज केप्ट अनचेंज्ड, और x प्लस 4 यानी सेकेंड फंक्शन का हम लोग डिफरेंशियल कोएफिशिएंट यहां पे कैलकुलेट किए हैं. सो x प्लस 4, इफ यू डू ddx ऑफ x प्लस 4, इट कम्स टू 1. डिनोमिनेटर वी नो v स्क्वायर देना है, v इज द सेकेंड फंक्शन. यहां पे डिनोमिनेटर क्या है, x प्लस 4, यानी x प्लस 4 इज द सेकेंड फंक्शन. So denominator becomes x plus 4 square. So if you simplify the numerator, it becomes minus 2 by x plus 4 whole square. Okay. So this is the, we have completed all the 4 basic rules. Now we will go to some of the next examples. We have derivative of a function of a function. So derivative of a function, a simple example, best example from the study material. Section 8A4, if you see, there are two questions here. First is you have log 1 plus x square. We have to differentiate this with respect to x. Now, if you see log 1 plus x square, 1 plus x square, if you see, is also a function of x. So what we are doing, we are assuming let y is equal to log 1 plus x square. And this is equal to log t, जहां पे हम लोग t क्या है, t हमारे लिए, we are assuming t equal to 1 plus x square. So the formula of dy by dx, we can easily do it like this: dy by dt into dt by dx, dy by dt into dt by dx. So इसमें हम लोग क्या करेंगे, first log t पकड़ के चलेंगे. Log 1 plus x square is now equal to log t. Why? Because we have assumed 1 plus x square is equal to t. So what we have done, log t, if you have to do dy by dt and your expression is log t, we know dy by dt, where the function is log t. Log t का differential coefficient क्या है, 1 by t. But here t is 1 plus x square. So नीचे क्या आएगा, denominator में आ जाएगा 1 by 1 plus x square. But we have another function here, and that is, if you see dt by dx, 1 plus x square, इसका भी differential coefficient निकालना है. 1 plus x square, the differential coefficient becomes 2x. 1 plus x, apply your fundamental principle, what we have covered. 1 plus x square, ddx of 1 plus x square, ddx of 1 is 0, ddx of x square is 2x, yani 2x आएगा. So 2x comes in the numerator because the formula is dy by dt into dt by dx. So we are getting 2x divided by 1 plus x square. So this is derivative of a function of a function. Last one is implicit function. Implicit function क्या है? Implicit function is if you get a form like, let us take the example here, x square plus y square. That means the function is not purely fx. It's a function of both x and y. You can see in this example, x square y square plus 3xy plus y equal to 0. So here you cannot find out the differential coefficient of y because the function is composite. इसमें जो करना है, what we have to do in this case is that we have to rearrange and we have to differentiate both the sides with respect to x, and we will do some substitution. So let us take a solved example, x square y square plus 3xy plus y equal to 0, and let us try to see what we are doing. Now please note we have x square y square plus 3xy plus y equal to 0. In other words, we have an implicit function because we have both x and y together. We have both x and y. So यहाँ पे जो हो रहा है, if you see in case of implicit function, what is happening is since we have both x and y, we are differentiating both the sides, and क्या आएगा? Now x square, please see x square y square. So what we are doing, we have a product plus we have 3xy plus y. So what we are doing here is first x square y square. So what we are doing, x square we are keeping it unchanged. ddx of y square. ddx of y square is 2y into dy by dx. Plus the next part is 2xy into 2, because if you see the next part, we have taken x square y square, we have taken up first the first part x square into ddx of y square, which is x square into 2y, y square will become 2y into dy by dx, plus we have the y, you are getting a type of a function which is a function of a function. For example, if a question comes that you differentiate, okay, if you get a question like this, that you say, for example, you find out log 1 plus, chaliye, easy lete, okay, log x square plus 2x plus 1, log x square plus 2x plus 1 with respect to x. So if you see, here we have function of a function. So what we have to do, we will first take, let x square plus 2x plus 1 equal to t, like in this example we have taken. So log t, so simplify karna hai. X square plus x plus 1 we are taking as t. So if it is equal to t, then dt by dx we can find out. So this will be equal to how much? We have log t means it is 1 by t. 1 by t aa gaya. But t is x square plus x plus 1. So in the denominator, 1 by t, I will replace t by x square plus x plus 1. Of x. X square plus x plus 1 iska jo differential coefficient, we also need to find it out. X square plus x plus 1 differential coefficient is 2x plus 1. So therefore the answer will be 2x plus 1 divided by x square plus x plus 1. This is a function of a function. Okay, we will do some more problems and you will get full understanding. Please practice, because please remember that it is important to practice these problems as many number of times so that you get complete clarity. In fact, these two areas in differential calculus, if you see, implicit function and the function of functions, these are a little more critical than the previous part. Okay. So this is implicit function. Once again, dy by dx equal to dy by dv into dv by dx. So here you see y is a function of v and v is a function of x. Please see. Like as you saw that if y equal to log 1 plus x square, fine. That means what is happening? Y is a function of v. But v, ye 1 plus x square is also a function of x. So that is why it is called implicit function rule. And here we are using the same principle as we saw earlier. We will go to the exam questions and we will see how many types of implicit function questions have come. We will try to do it as well. Lastly, we have inverse function rule, which is the last part of our study material, one of the last parts, and then we will go to the higher order differentiation. So here we have if dy by dx, if x is equal to fy, then dy by dx is equal to 1 by dx by dy, just the reverse. Okay. This is a very simple understanding illustration, and you can just go through it. So if y equal to 4x cube, then dy by dx is 12x square. So dx by dy has to be the reverse, 1 by 12x square. Okay. Parametric. Okay, let me go to this one. Okay, differentiate log 1 plus x square with respect to x. We have just solved it. We will take that, let y equal to log 1 plus x square equal to log t. T is equal to 1 plus x square. So first we find out dy by dt. Please see that now this is implicit. Log y is now equal to y is equal to log t. So dy by dt in this case is log t differential coefficient, जो कि 1 by t आएगा. But then we multiplied by dt by dx because log t, यानी log 1 plus x square is a function of x. So dy by dt into dt by dx. dt will cancel out. You will get dy by dx. Okay, the last one we have is logarithmic differentiation. ये भी it is a combination of your differential calculus and your earlier chapter on logarithm. So sometimes you will get the application of these type of specific differentiation in the exam. And let us take the example x to the power x. X to the power n we have done. X to the power n is n into x to the power n minus 1. उसका differential coefficient simple. लेकिन x to the power x होने से क्या करना है? So in this case, it is better to take the log of both sides. So if you get such a question in the exam, we will just write let y equal to x to the power x. अभी दोनों तरफ, both the sides we will take log. So if y is equal to x to the power x, then log y will become what? Log x to the power x. But we know log x to the power x is nothing but x into log x. Because we know log a to the power m is equal to m into log a. So we are simplifying. Then it becomes easy for us to differentiate, क्योंकि अभी differentiation will become just a one-step process. There is a numerical, very popular numerical which is there in the study material. If x to the power m into y to the power n is equal to x plus y to the power m plus n, then prove dy by dx equal to y by x. It is there in the study material and you can just go through it. The same principle where we take log of both the sides and then simplify it according to the terms and conditions of logarithm. Then we get dy by dx, and by transposing different terms from one side to the other side, we are able to obtain the value of dy by dx. Okay. Now it's time to go for the last part, which is the higher order differentials. So differentiation, differential calculus deals with dy by dx. So we have a expression here. We have an expression fx equal to x to the power 4 plus 5x cube plus 2x square plus 9. So we are finding out the differential coefficient using the principles we have already covered. So x to the power 4 becomes 4x to the power 3, 5x cube becomes 15x square, and 2x square differential coefficient comes to 4x. Fine. But can we differentiate this expression once again? That means, can we differentiate dy by dx again? So this is called higher order differentiation. That means for first order, we use the term dy by dx. For the second order differentiation, we shall use d square y by dx square, which denotes it is a differential of the second order. That means this is a second degree differentiation, second time differentiation. So 4x cube plus 15x square, if I try to differentiate this once again, well, I will write d square y by dx square, because this is a second order differentiation. 4x cube becomes, if you do differentiation of 4x cube, ये क्या होगा? ये आ जाएगा 12x square. 4 into 3, 12 into x to the power 3 minus 1, यानी 12x square. 15x square will become 15 into 2x, यानी 30x. 4x का डिफरेंशियल कोएफिशिएंट 4 रहेगा। सो डी स्क्वायर वाई बाई डी एक्स स्क्वायर, यानी सेकेंड टाइम जब हम लोग डिफरेंशिएशन कर रहे हैं, यानी F2 you can call it, F double slash, it comes to 12x square plus 30x plus 4. Can we have the third round of differentiation? Answer is yes. D cube y by dx cube, yani third differential. 12x square plus 30x plus 4, if I differentiate it once again, it comes to d3y, or d, you can call it the third differential. We are getting 12x square. Again we are differentiating. It will become 24x plus 30x, हम लोग का है वहां पे एक्सप्रेशन में, उसको अगर डिफरेंशिएट करेंगे इट बिकम्स ओनली 30. सो द थर्ड डिफरेंशियल, थर्ड ऑर्डर डिफरेंशियल becomes 24x plus 30. Please see this example given. This is a previous year exam question. So y is equal to 3 by x. We have to find out the third differential. यानी हम लोगों को क्या करना है, वी विल फर्स्ट डिफरेंशिएट, dy by dx निकालेंगे, 3 by x का dy by dx अगर करेंगे, इसका क्या आ रहा है आंसर, -3 by x स्क्वायर. d1 हो गया. नाउ सेकंड डिफरेंशिएशन, d2, d स्क्वायर y by dx स्क्वायर, यानी सेकंड डिफरेंशियल. नाउ वी हैव द एक्सप्रेशन -3 by x स्क्वायर. इसको फिर से डिफरेंशिएट करने से द आंसर कम्स टू 6 by x क्यूब. And finally, when we tried the third differential, that is the third time we are differentiating the expression, we are getting dy by dx, but this is third time, so d cube y by dx cube, we are getting -18 by x to the power 4. So this is the concept of multiple differentiation, which we will, or sometimes we call it, as I said, the first order derivative. So first order derivative is shown by f dot x. Second order derivative is shown by f double dot, yani ddx of dy by dx, that is d square y by dx square. और जब हम लोग तीसरे बार करेंगे, it is denoted by y triple slash or y within bracket 3. That means it is d3y by dx3, third time differentiation. Okay. So this is the three levels of differential. We can do it n number of times, of course. If the expression is amenable, if the expression can be differentiated further, yes, we can differentiate up to nth time. Okay. Last, we will see some questions from the tangent, slope and tangent. So we will first see that the differential coefficient, uska ek bahut bada practical example, practical application is, you have a curve. Now we want to find out the slope of the curve. Slope यानी gradient. So उसमें क्या करना है? We just need to differentiate. यानी we need to, if we have the equation of the curve, we will just differentiate it and we will get, what we will get is basically the intercept or the slope. Gradient. In geometry you have learnt about gradient, slope. So let us see the particular example. From the study material, it is a very common type of question which you might be facing in the exam, and similar questions have come in the previous years. The question is very simple. Find the gradient of the curve. Here you can see it on the right hand side of the slide. Find the gradient of the curve 3x square minus 5x plus 4 at the point 1, 2. यानी एक curve है y equal to 3x square minus 5x plus 4. We need to find the gradient of the curve, slope of the curve at a particular point. Please imagine a curve, freehand curve. Curve is moving up and down. Curvilinear. It is not linear. It is not straight line. It is curvilinear, curve. Now the slope, gradient will change from point to point. The question is asking us that find out the gradient of the curve at a specific point. और वो पॉइंट दिया हुआ है 1, 2, यानी x इक्वल टू 1, y इक्वल टू 2. उस हिसाब से सोचिए. सो पहले हम लोग क्या करेंगे, द एप्लीकेशन ऑफ डिफरेंशियल कैलकुलस, वी विल फाइंड आउट द डिफरेंशियल कोएफिशिएंट ऑफ दिस कर्व. ये जो कर्व है ये सेकंड ऑर्डर है क्योंकि x के ऊपर 2 लिखा है. x का जो पावर है वो 2 है. सो हियर वी विल अप्लाई dy by dx. We will practically do the differential coefficient of 3x square minus 5x plus 4. dy by dx करने से आंसर आ रहा है 3x square का differential coefficient क्या होगा? 6x. Using the fundamental principle. Minus 5x. Minus 5x. Differential coefficient will be simply minus 5. So अपना dy by dx निकल गया 6x minus 5. अब क्वेश्चन में ये बोला गया कि एट द स्पेसिफिक पॉइंट 1 2, दैट मीन्स x का वैल्यू 1 है. कोई भी कोऑर्डिनेट, अब सोचिए ज्योमेट्री, कोऑर्डिनेट ज्योमेट्री, कोई भी पॉइंट, you think of latitude, longitude. So you have latitude and longitude. So you know there are basically we have two different parameters to locate a particular point on the surface of the earth. अब GPS सोचिए. In GPS you have 3 points. Any point in space, it has 3 coordinates. It will have a linear coordinate, it will have length, breadth as well as height. Similarly, in this particular case, you can see that here we have, it's a 2-dimensional space. एक कर्व है, एक पेपर के ऊपर मैंने कर्व ड्रॉ किया. We have to find out the gradient at a particular point. The point coordinate is 1 and 2. So gradient हमने निकाल लिया. We have got the differential coefficient 6x minus 5. Now at x equal to 1, when we are putting the value of x equal to 1, we are getting the value is 6 into 1 minus 5, yani gradient is 1. So this is as simple as this, and you just need to find out the differential coefficient and then put the particular value which is given in the problem. Okay, one question has come: for what reason we do multiple times of differentiation? So this has come from Miss Tejaswini. Yes, we will do multiple times differentiation, especially when we come for maxima minima calculation. And you will see it has a direct application with commercial studies, with economics, because this is the last part of our chapter today, where we will discuss the application, why we are doing multiple times of differentiation. Because we want to find out the best example why we do multiple times of differentiation is to find out the maxima minima, maximum revenue, minimum cost, all these parameters, right? Okay. Yeah, implicit function we will do once again through number of examples. We will go for the exam questions, MTP, almost 20-25 questions we will be doing. So application, you can see, ये जो अभी multiple differentiation, gradient निकालेंगे, ये सारे applications, it has tremendous applications in, of course, in physics. Even if you see in economics, a lot of applications we have of calculus. आप कोई भी economics का कोई भी टेक्स्ट बुक आप खोलिए, उसमें डिमांड, सप्लाई, प्रोडक्शन, कोई भी चैप्टर देखिएगा. In economics also you will remember there is always the concept of demand and supply. If the price goes up, what is the proportionate change in the demand? If the supply falls, what will happen to the price? So please see, the whole world economy ultimately revolves around these simple principles: demand, supply, price, quantity. And if you see, dear students, these are linked with each other. Very similar to differential coefficient, because in differential coefficient we have discussed that a small change in the independent variable x can create a change in the dependent variable y. And this relationship is captured through differential coefficient. Similarly, just imagine, if the cost of living goes down, maybe I am able to save more. If my income goes up, maybe I am able to save more. Maybe if my income goes up by 10%, I can save 15%. So they are related to each other. One of them is dependent, one of them is independent. So various scientific formula, rate of change in price, rate of change in demand, you can see all these points are there. If there is a change in the income level, demand can change for certain commodities. So this is the practical application. Now we come to the cost function. You all know that the total cost equals variable cost and fixed cost. And here you will see I will say it is a combination of mathematics and economics. This is the best part of calculus. So up till now, whatever we have discussed and the formula and the basic principles we have analyzed through number of examples, practical examples. Now we will see the application of differential calculus in business economics, and commerce. So as a result, we look at some of the basic formula which all of you are well acquainted with. Cost function is equal to the cost, total cost equals variable cost plus fixed cost. You also know if the total cost is given, you can easily find out the average cost, total cost by output. Similarly, the average variable cost, average fixed cost you can find out. In economics, you have learned about marginal utility, marginal cost. So what is marginal cost? The additional incremental cost of producing one additional output, one additional unit of output. We can say it is a marginal cost. Or conversely, we can say marginal cost is the rate of change in cost per unit change in the output. So therefore, we will look at now the application of differential calculus in economics. So all these formula are well known to you. Total cost equal to FC plus VC. Total revenue is, you know, the price into quantity, individual price per unit into quantity. Profit is equal to total revenue minus total cost. So these are very simple and understandable, plus all of you are aware about this. And one more point is break-even point, which you have probably gone through. Break-even point means a point where there is neither profit nor there is any loss. That means profit is zero. This is basically the point where the total revenue is equal to total cost. That means neither am I earning any profit nor am I incurring any loss. In the language of economics, we can say it is, you may remember, a point, indifference point. I hope you remember indifference point. So this is usually denoted by break-even point. Profit is maximized when marginal revenue is equal to marginal cost. Now let us see what happens. How do we find the marginal functions? So let us see the first example from the study material. Total cost is given 1 by 3x cube minus 5x square plus 28x plus 10. ये आपका cost function है. Cost depends on various parameters, and definitely you will definitely agree that cost is a function of the output. In other words, आप जितना output बढ़ाएंगे, आपका cost उतना ही बढ़ेगा, and the reverse is also true. Now, there is an imposition of tax. A tax at the rate of ₹2 per unit is imposed, and the producer adds it to his cost. If the market demand is given where P is the price per unit, find the profit, maximizing output and price for maximum profit. So इसमें क्या है कि after the imposition of tax is added, अभी क्या है कि इनका tax है 2 per output और output हम लोग का है x. It is given. So therefore the additional cost on account of tax is 2 into x, yani 2x. So if you see, the total cost function now becomes 1 by 3x cube minus 5x square plus 28x plus 10, जो already दिया है. उसके साथ we have added 2x to reflect the cost on account of tax, which the producer is trying to include in the cost. Revenue we know is P into X. And accordingly, what we are doing is we are finding out the particular price is given, of course, where we are finding out the particular output at which profit is maximum and the output where the profit is maximum and the price for the maximum profit. So both can be done. We will take some more examples. Our firm faces a demand curve 17 minus 3Q, where Q is the quantity. Demand is 17 minus 3Q. Find an expression for total revenue in terms of Q. Find an expression for marginal revenue. So what is the solution? P equal to 17 minus 3Q, where P is the price and Q is the quantity. So what is total revenue? Total revenue we know is equal to price into quantity. Price is 17 minus 3Q and quantity is Q. So आपका total revenue क्या होगा? P into Q, यानी 17 minus 3Q multiplied by Q. So आपका total revenue क्या निकल रहा है? 17Q minus 3Q square. So we have solved the first part. Second part, find an expression for marginal revenue. Please remember, this is where we get the application of differential calculus. Marginal revenue is nothing but the differential coefficient of total revenue. So when you have total revenue equal to 17Q minus 3Q square, उसका अगर हम लोग differential coefficient निकालेंगे, we are getting DQ of 17Q minus 3Q square, ये आएगा 17 minus 6Q. So you can see we have got the expression for the marginal revenue. Marginal revenue is nothing but the differential coefficient of the total revenue. Similarly, please remember that marginal cost is the differential coefficient of the total cost function. Okay, we take the second example. Total cost curve is given. Find an expression for average cost. Second question, find an expression for marginal cost. And the third question, when does average cost equal marginal cost? Typical question, very suitable, or I would say very common type of questions keep coming in the exam. So here we have total cost is given. We know, पहले हमको क्या करना है? First question asks us to find out the average cost. What is the average cost? Average cost is total cost by quantity. So total cost दिया हुआ है Q cube minus 4Q square plus 12Q. इसको अगर हम लोग ये जो एक्सप्रेशन दिया है इसको अगर हम लोग Q के द्वारा डिवाइड करें, that is the formula is TC by Q, you will get average cost. So therefore average cost will become, if you divide Q cube, that is Q to the power 3 minus 4Q square plus 12Q. If you divide it by Q, you will get Q square average cost. Q square minus 4Q plus 12, you can see on the right hand side. Now the next question is marginal cost निकालना है. Marginal cost is nothing but the differential coefficient of the total cost. So total cost यानी Q to the power 3 minus 4Q square plus 12Q. If you kindly find out the differential coefficient, you will get dTC by dQ is 3Q square minus 12Q plus 12. Sorry, 8Q. 4Q square है यानी 8Q plus 12. It becomes 3Q square minus 8Q plus 12. This is your marginal cost. Finally, when will the marginal cost equal to the average cost? Just equate the two equations. Already we have got average cost यानी Q square minus 4Q plus 12. And we have got the marginal cost equation. AC and MC, once we equate, we are getting the particular quantity Q equal to 2. So this is how we have to find out all these. We have to solve these questions. Last one is maxima minima. This is where we look at the second order differentiation. So इसमें जो करना है, when the function is given, cost function is given, first we will find out the first order differential, that is dC by dx in this case, and then जो differential coefficient निकलेगा, we will set it to 0. We will equate it with 0. From there we will get a value of x, and then we will differentiate the particular expression once again. That means we will go for second order differential. Second order differential जो आंसर आएगा, जो expression आएगा, उसमें हम लोग x का value put करेंगे. If the value is exceeding 0, then it means that the point we have got is a minima. And if the value is less than 0, then we know that the point we have achieved is a maxima. So we will see an example and then we will solve it. We have some examples from the exams. Okay, this we have discussed, marginal cost. Okay, let me go to the exam questions now. Okay. First, before that, just last point of our chapter, we were discussing that another application of differential calculus, we have two last terms. First is MPC, marginal propensity to consume. So marginal propensity का अर्थ होता है कि propensity means tendency. Okay. So marginal propensity to consume means it captures the relationship between the total consumption and the total income. That means if there is a rise in income, there could be a rise in consumption and vice versa. So the marginal propensity to consume is nothing but the rate of change in the consumption per unit of change in the income. So kindly see the similarity between the concept of differential calculus dy by dx and MPC, which is marginal propensity to consume. Both are actually capturing a ratio, a rate of change. A rate of change in the dependent variable due to a small change in the independent variable. In this particular case of marginal propensity to consume, if you see which one is the independent variable? Independent variable is the income. Dependent variable is the consumption. Okay, so therefore it is nothing but direct application of differential calculus. Similarly, marginal propensity to save, this is nothing but the reflection of the relation between income and savings. So the proportionate change in the savings on account of change in the income. So as my income increases, consumption will also increase. As my income increases, savings may also increase. And vice versa. As my income reduces, usually the consumption will reduce. Plus, if my income reduces, usually in general parlance, the savings potential will also reduce. Okay, so now we come to the last few questions on model test paper. So kindly go through the MTP, and the question is the first one, equation of the tangent to the curve x cube minus 2x plus 3 at the point 2 and 7. So we have done a similar problem earlier. Simple question, इसको पहले हम लोग differentiate करेंगे क्योंकि tangent निकालना है. X cube minus 2x plus 3. If you find out the differential coefficient, ddx of x cube is 3x square minus 2x है, यानी ये हो जाएगा केवल 2. So the differential coefficient is becoming 3x square minus 2. The point is given 2, 7. That means x is 2. 2, 7 point means what? It's a coordinate. X is 2, y is 7. So we are putting x equal to 2. किसमें पुट करेंगे? ये जो differential coefficient we have brought out, 3x square minus 2. Once you put the value x equal to 2, you are getting 3 into 2 square minus 2. That means it comes to 10. So the answer is y equal to 10. That means the equation of the tangent is y equal to 10. Fourth answer is option number 4 is correct. Next question. This is like parametric equation. One of you were asking. I said that we will do similar problems. X is equal to ct, y is equal to c by t. फिर dy by dx क्या है? Very simple. Friends, please do the calculation with me. So इसमें दिया है कि x is equal to ct, y equal to c by t. So formula क्या है parametric में? dy by dt into dt by dx. dy by dt into dt by dx. So mentally आप mapping करो, dt cancel हो जाएगा. So dy by dt क्या है? यहाँ पे y is c by t. So dy by dt अगर आप करेंगे, dy by dt, that means y is c by t. So इसका निकलेगा minus c by t square. Just write it out. C by t है, यानी c into t to the power minus 1. So इसका differential coefficient निकलेगा minus c by t square. This is dy by dt. Now you have x. X is ct. So dx by dt क्या होगा? Only c आएगा. dx by dt means you are differentiating x with respect to t. X is c into t. So इसका क्या आएगा? c by t. Only c, because you are differentiating x. X is c into t. So d dt of ct. ct को आप differentiate कर रहे हो with respect to t. इसका आंसर आएगा केवल c. So now we have the final answer, dy by dx equal to dy by dt into dt by dx, where dy by dt is what? We have already found out, minus c by t square. और अपना dx by dt क्या आया है? dx by dt has come to c. but we have to find out dt by dx, reverse. So it will become 1 by c. So ultimately the expression becomes minus c by t square into 1 by c. C and c will cancel. The answer will be minus 1 by t square. Yani option C is the right answer. This is the parametric equation. Gradient of the curve, ये भी सही है. This is similar question. You can try it out and check the answer. Just let us do it alongside. We have the curve 3x square minus 5x plus 4. Please find out the gradient. That means you have to differentiate. You have to just find out the differential coefficient of this expression. Y is 3x square minus 5x plus 4. Yani it's a function of x. It is nothing but a function of x. So once you find out, if you just do it, what you get is dy by dx equal to 3x square का आपको निकालना है. You have to find out the coefficient, differential coefficient. So it becomes 6x minus 5x, yani 5. So the differential coefficient becomes 6x minus 5. Point is 1, 2. So we have to put x equal to 1. So 6x minus 5, this is the expression. You are putting x equal to 1. So the answer comes to 6 into 1 minus 5. That is 6 minus 5. So the answer is 1. Okay, this is also a past model MTP question. Derivative of e to the power x log x we have already done. Next question, if you see, find the gradient of the curve 3x square minus 6x plus 4 at the point. A very similar type of question. You can see it has come in the MTP. So you can just try it out and check how we are doing it. Yeah, difference in gradient and tangent. Gradient is the slope. Okay, so tangent is the straight line. Mr. Karthik has asked this question. So tangent is the straight line which touches a curve. Okay, gradient is the slope of that tangent. Gradient means slope. Okay. So ये जो है gradient of the curve at the point. So first we are finding out कि basically they are saying कि first we find out the tangent. Tangent जो है उसका gradient निकालना है. Tangent क्या होगा? We are finding out the differential coefficient. Y is 3x square minus 6x plus 4. What will be the differential coefficient? So it will become 6x minus 6. 6x minus 6. Fine. X point, what is the point? X is 1, y is 2. So we will take x equal to 1. Expression we have got. यानी जो tangent है उसका equation है 6x minus 6. Point चाहिए at the point 1. Yani we will put x equal to 1. So 6x minus 6. The expression is 6x minus 6. For x equal to 1, we will get 6 into 1 minus 6. That is 6 minus 6, yani 0. Yani gradient is 0. Okay. Next, we will go to the last few questions. Okay. Derivative, this we have already done. 8x square minus 2x plus 5. This similar type we have already done. Now MTP 2025. The slope of the tangent to the curve. ये जो अभी Mr. Karthik was asking कि slope, what is gradient and tangent? I was explaining. Tangent is a straight line which touches a curve. उस tangent का gradient and slope is same. Just think of gradient. How steep is it? Rasta, mountainous road. You can find out the gradient. Okay, slope. So यहाँ पे दिया है कि the question is y equal to x square minus x. We have to find out what is the slope of the tangent. So let's see the solution here. Y is x square minus x. At the same time, they are clearly saying कि ये जो curve है, इसको एक straight line is cutting and the straight line is y equal to 2. So on the one hand, we have y equal to x square minus x, which is a curve, and the straight line y equal to 2, they are cutting it. Okay, so that's why I have taken some questions from the MTP, the mock test paper. And if you see here, we are equating both of them. So what we are getting, if y is equal to x square minus x, also y is equal to 2. If you equate both the expression, we are getting x square minus x equals to 2. That means x square minus x minus 2 is 0. So it's a quadratic equation. If you break up the quadratic equation, you are getting basically two factors, factor number 1 x minus 2 and the second factor x plus 1. You can see step by step I have prepared the solution. If x minus 2 is equal to 0, then x will be 2. And if x plus 1 is 0, then x will have the value of minus 1. बट अगर आप गौर से प्रॉब्लम को दोबारा पढ़े, वहां पे साफ लिखा है दैट द कटिंग, दैट मींस दिस टेंजेंट इज कटिंग द कर्व इन द फर्स्ट क्वाड्रेंट. फर्स्ट क्वाड्रेंट, you know we have four quadrants. Okay, so in the first quadrant, so first quadrant means x must have a positive value. So there are two possible values of x. One is x equal to 2 and the other is x is minus 1. But since the problem specifies that everything is being done in the first quadrant, so we have to take the positive value of x. So we are taking x equal to 2. Finally, we are finding out the differential coefficient of the curve. And this comes to d dx of x square minus x, which is 2x minus 1. So 2x minus 1 and the particular value of x is 2. We have already got it 2. So if you put x equal to 2 in this particular tangent equation, you are getting at the point x equal to 2, tangent का जो slope है यानी 2x minus 1, जहां पे x का value 2 है, so the tangent slope becomes 2 into 2 minus 1 yani plus 3. So this is a very interesting question and I hope you have understood. We have done the detailed discussion. The next few questions, last 4-5 questions we will take. If the total cost of producing x units of a commodity is given, marginal cost nikalna hai when x is 5. So we already know that total cost function, when we differentiate the total cost function, we get the marginal cost. So total cost function is there. So we are differentiating each of the term. यानी 1 by 3x cube plus 2x square अगर हम लोग करेंगे, you will see dc by dx. Here c is the cost function, c. We are differentiating c with respect to x. जैसा dy by dx वैसे dc by dx हम लोग कर रहे हैं. So we are getting x square plus 4x minus 5 if you differentiate this expression. The question is, this is a marginal cost equation. Now when x equal to 5, easy, ये जो इक्वेशन है उसमें x equal to 5 इक्वेट करके आप वैल्यू निकालिए. So we are getting when x equal to 5, this equation x square plus 4x minus 5 becomes 5 into 5 यानी x square यानी 5 square plus 4 into 5 minus 5. So 40. So you are getting the marginal cost when x equal to 5. यानी जब output is 5, the marginal cost comes to 40. Okay, this is also a very typical exam type of questions. And if you practice all of this, you can get two things. First is you are getting more command over differential calculus. Number two, you are able to see the connectivity between differential calculus and economics and commerce. And of course, needless to mention, you are getting ready for the exam as well. Okay. Another question, if the total cost function of producing x units of a commodity is given by the equation 360 minus 12x plus 2x square. आपको क्या निकालना है? Then the level of output at which total cost is minimum. So यहां पे शायद हम लोगों को maxima minima यूज करना पड़ेगा. Let us see. Options are given, but first please see the total cost function is given. Question is, what is the level of output at which total cost is minimum? So सबसे पहले what we do is we differentiate the given expression. So total cost is given 360 minus 12x plus 2x square. We are differentiating क्योंकि हम लोग को minimum निकालना है. dTc by dx, if you do it, ddx of 360 is constant, 0 हो जाएगा. Minus 12x, वो खाली minus 12 आएगा. Plus 2x square, इसका ddx करने से 4x आएगा. So 360 minus 12x plus 2x square, the first order differential, that is dc by dx, comes to minus 12 plus 4x. Fine. Now according to the law of maxima minima, ये जो अभी expression आया है, we have to equate it to 0. So we have to set it to 0. यानी -12 plus 4x equal to 0. Therefore x equal to 3. If x is equal to 3, very good. Now we go for the second order differential. Second order differential करने से, that means now we are doing ddx of -12 plus 4x. Second order differential. This will give us 4, and 4 is more than 0. That means this particular point is the minima. X equal to 3 is the minima. So question was, what is the level of output at which total cost is minimum? So we have received the minimum figure, x equal to 3. That means at x equal to 3, when the output is 3, this function will have the minimum value. Yes, it is done by method of differentiation. Yes, Mr. Karthik. Exactly. We have done it by differentiation. Minima is at x equal to 3. Next question, very important. इस साल का मतलब MTP 2026, I'm sure you have gone through it. X to the power y into y to the power x is 16. What is the value of dy by dx? इसको पूरा the formula we have to apply is logarithmic differentiation, logarithmic. So taking log of both the sides, we find out x to the power y into y to the power x equal to 16. So when we take the log of both the sides, please see what I have done. Log x to the power y into the y to the power x is log 16. We are taking log of both the sides. Now we differentiate both the sides. We know log x, differential coefficient is 1 by x. So using the principle, we are finding that dy by dx, if you calculate in this way, dy by dx, we are getting the value is minus y log y divided by x log x. By differentiating and then by transposing, we are getting this formula. dy by dx relation minus y log y divided by x log x. Now, in the question it is mentioned, the coordinates are there. कौन सा value? X is 2, y equal to 2. So at x equal to 2, y equal to 2, this expression dy by dx becomes minus 2 log 2 divided by 2 log 2. क्योंकि x भी 2 है, y भी 2 है. X का value भी 2 है, y's value is also 2. Naturally, dy by dx becomes minus 2 log 2 by 2 log 2. So it becomes, answer is minus 1. Okay. Okay. I will go back to the last question. Miss Muskan is asking previous question. Previous question, we will go to the last question. Okay. Dubara, I'll just, yeah. This was the maxima minima. So we saw this equation is given 360 minus 12x plus 12x squared. So the question is, what is the output at which this particular expression, yani total cost is minimum? So the formula, the method is very clear. We have to find out the differential coefficient. First we find out the differential coefficient, and जो भी differential coefficient आएगा, we have to equate it with 0 so that we can get the possible value of x. We have done the same thing here and we are getting x equal to 3. Okay, the moment we are getting x equal to 3, we will now go for the second order differentiation. Just to be on the safer side, here we see that the second order differentiation comes to how much? It is coming to 4, because ddx of minus 12 plus 4x will give you basically 4. 4 is more than 0. 4 is positive. That means the minima was at x equal to 3. If the second order differential becomes negative, that means the point was a maxima. Okay, so that is the rule. Okay, I have explained it once again. Now we go to the next question, maxima minima of the function. So one more question to explain maxima minima. So the maxima and minima of the function 2x cube minus 15x square plus 36x plus 10. चलिए इसको निकालते हैं. इसका पहले हम लोग डिफरेंशियल कोएफिशिएंट निकालेंगे. So एक साथ करते हैं. Let us do it one by one. So सबसे पहले हम लोग इसका डिफरेंशियल कोएफिशिएंट निकालेंगे and we will set it to 0. So dy by dx करिए. 2x square becomes 6, 2x cube sorry becomes 6x square. फिर क्या है माइनस 15x स्क्वायर, इसका डिफरेंशियल कोफिशिएंट आएगा माइनस 30x. उसके बाद है प्लस 36x, इसका डिफरेंशियल कोफिशिएंट कमिंग टू प्लस 36. We will set it to 0. This is the formula. We will set it to 0. That means the equation becomes x square minus 5x plus 6 equal to 0. It's a quadratic equation, यानी इसका दो फैक्टर या रूट आएगा x minus 3 into x minus 2. Yani x has a value either 2 or 3. It is now having two roots, x equal to 3 or x equal to 3 or x equal to 2. Now the question is, if x is equal to 3 or x equal to 2, we don't know which one will give us maxima minima. So what we do is we now go for the second order differentiation. First order we are getting x square minus 5x plus 6. सेकेंड ऑर्डर डिफरेंशिएशन कर रहे हैं यानी डी स्क्वायर वाई बाई डी एक्स स्क्वायर कर रहे हैं. वी आर गेटिंग 2x minus 5. Now in this 2x minus 5 we will put both the values to find out which value gives us maxima, which value gives us minima. So we have got two alternate values, x is either 2 or x is either 3. So in this second order differential 2x minus 5, we are first putting x equal to 2. If you put x equal to 2 in 2x minus 5, you are getting the answer is minus 1. Minus 1 is less than 0. That means this is the maxima. Yani for the value x equal to 2, this function will have maximum value. Now we put x equal to 3 in the equation 2x minus 5. So we are getting in the expression 2x minus 5, when you put x equal to 3, you are getting the value is 1. 1 matlab it is more than 0. That means this is the point of minima. Therefore, the solution is option A is correct. When x is equal to 2, we are getting the maxima. When x equal to 3, we are getting the minima. Okay. ये जो है आप जो बोल रहे हो हाउ इट इज इक्वल टू 0, ये डिफरेंशियल जब होता है व्हेन वी आर डूइंग द मैक्सिमा मिनिमा, वी हैव टू इक्वेट इट टू 0. ओके, सो 2x minus 5 आप जो देख रहे हो, this is the differential coefficient. Please see, this is the differential coefficient because the given equation is what? First equation is 2x cube minus 15x square plus 36x. So we have done dy by dx first. Okay, we are setting this to 0. We are getting two values of x. And now we are taking the second differential. There we are going to put the value of x and we will check whether it gives us more than 0 or less than 0. If it gives us more than 0, that means we will say that it was a minima, and if it is less than 0, then it is a maxima. So you can see exactly as per the method we have followed, we are getting d2y by dx2 is 2x minus 5. Okay, why 2x minus 5? Because you can see ये जो 6x square minus 36 plus 30x plus 36 है, इससे आप 6 कॉमन ले लीजिए, just take 6 common, you will get x square minus 5x plus 6 equal to 0. जैसे आप ये expression आपको मिलता है, from here you just do the second order differential, you will get 2x minus 5. ये जो 2x minus 5. So dy by dx ये जो है, इसको हम लोग क्या कर रहे हैं? We are taking 6 common. If this is equal to 0, if 6x square minus 30x plus 36 equal to 0, then automatically by taking 6 common, whatever you are left with will also be equal to 0. So x square minus 5x plus 6 is 0. Once we differentiate this, we are getting 2x minus 5. Accordingly, I hope the remaining part is easy. Please study once again. Every subject looks confusing. Please study once again. You will understand. Go through the video and go through the question once again. This is maxima minima, the last part. Okay. So please go through it and practice. That's why I am completing each and every type of question, multiple examples so that you understand. Okay. Now we take the last exam questions. You can see the cost of this is exam question from January. Go through the video once again and practice the problems from the study material, MTP, and you will get better understanding. Okay. So first we are now going to the, let me just go to the question. Yes. Yeah. We are going to the, just a moment. I'll just go back to the slide. Let's go to the exam questions now. This is January 2026. The first question, please see the cost of production. I think this slide is visible. Yes. The cost of production of an item is given by C equal to 50x minus 5x square plus x cube by 6. Cost of production is given. If the average cost and marginal cost are equal, then what quantity of item should be produced? Right. Let us see this. So the cost is given. You have to find out if the average cost and marginal cost. So let us first find out the average cost. So iska average cost, how to find out the average cost? So we know we are given this particular expression. So let us find out the average cost now. C equal to 50x minus 5x square plus x cube by x. So the average cost is how much? If you divide this expression, then you are getting the average cost. That will be 50 minus 5x plus x square by 6. So you can easily find out the average cost, and from there you can, just 1 minute. I'll just stop the share and restart once again from there. Just give me a moment. Let me just share it once again. Okay, I think the slide is visible. Yes. Yeah. The cost of production. So first we are finding out the cost is given. Please find out the average cost. So once you have the cost, you can easily find out the average cost. Thirty-six question, I'll come to 36. Last step. Okay, I'll just come to that. Miss Muskan, just wait for some time. 36th question. Okay, let me just go back if possible. Let me see. 36th question you are saying. 36th is, that is 37. 36th question. I don't see any 36th question. Which one are you talking about? Okay, let me see if I get time at the end. Okay, let's come to this one, the exam questions now. So you have the total cost, you know the total cost. The question is if the average cost and marginal cost are equal. So please note this is from the final exams of the institute, that is from the actual exam. So please see here we have the average cost is total cost by the quantity, that is C by X. So you can see here we have the total cost is 50x minus 5x squared plus x cube by 6. Once you divide it by x, you are getting the full average cost. That is 50 minus 5x plus x squared by 6. This is the average cost. Now please note we have to find out the marginal cost. Marginal cost is nothing but the differential coefficient of the total cost. Total cost is 50x minus 5x square plus x cube by 6. What will be the marginal cost? Please find out the differential coefficient. 50x minus 5x square plus x cube by 6. इसका differential coefficient अगर निकालेंगे, it comes to 50 minus 10x plus यहाँ पे x cube है, यानी 3x square by 6 होगा, यानी x square by 2. Now we need to equate them because the question is if AC equal to MC. So equating the two expressions, these two expressions, once you equate, you are getting x square equal to 15x. That is either x is 0 or x is 15. Now x cannot be 0. So x has to be 15. Yani option B जो आप देख रहे हैं, that is the correct answer. So this is the exact question. Next question we have, if fx is equal to 3 into e to the power x square, then this expression क्या होगा? So this is something we already have done. Euler's number, and accordingly fx, first we find out fx. fx is 3 into e to the power x square. We have to first find out f dot x. I am just moving my cursor. f dot x. f dot x, ये जो expression है, f dot x is what? 3 will remain as it is. E to the power x square. This will become e to the power x square into 2x, क्योंकि x square differential coefficient is 2x. Next we have to find out f0. f0 means the given function at the value 0. So f0 you can find out, it comes to 3. Next we have f dot 0. f dot 0 comes to 0. So therefore the expression what we need to calculate is, please see the expression, f dot x minus 2x into fx plus 1 by 6 into this expression. If you put the values one by one, it comes to half. So option number C, 0.5 is the right answer. So in this question, you see in one question, all the testing is done. That means we have to find out the first order differential, plus it is not a simple differential because you have e to the power x square. Right, so this is very similar to dy by dt into dt by dx formula, and then we have to find out f0, f dot 0, and then find out the overall value of the expression, which comes to 0.5. Okay, the last question we will take, the cost function of a company is given, Cx is 600x minus 10x square plus x cube by 2. X is the output. You have to find the level of output at which average cost is minimum. The average cost has to be minimum. Now cost function is given 600x minus 10x square plus x cube by 2. Average cost means total cost by output. So therefore, if I look at the solution, total cost is given, average cost is the cost function by x. So if you divide the given equation 600x minus 10x square plus x cube by 2, if you divide it by x, you are getting 600 minus 10x plus x square by 2. Question ये है कि we have to find out the average cost has to be minimum, and at what level we need to find out. So this is a question of maxima minima once again. So ये जो expression है, इसको हम लोग पहले differentiate करेंगे. We will find out the differential coefficient and then we will set it to 0 as per the rule of differential of maxima minima. So if you do the differential coefficient of the average cost function, you are basically getting, if you set it to 0, you are getting minus 10x square. That means this will become minus 10x square plus you have minus 10x plus x square by 2. So you will get minus 10 plus x square by 2. That means 2x by 2. That means it is x comes to 10. Now to double check, we will do the second order derivative. And ये जो second order derivative है, if you find out the second order derivative of average cost, you will get x square. That means you will get x square. So you are getting ddx of 10 plus 2x by 2. So you are getting 2. Derivative comes to 2. 2x by 2, it is more than 0. That means here we have a minima. So minima is at x equal to 10. So out of the 4 alternatives, option C is therefore the right answer. So this is the maxima minima and the cost function, average cost function, all rolled into one. So this is a question which came in the exam. So for recap for the exams, please go through once again the limit, the definition of derivative, addition subtraction rule which we have covered, the product rule, that is where u into v right? You have Gx, which is a combination of two different factors, Ux and Vx. Then you have the quotient rule, which we have discussed in detail. Implicit functions, we have done logarithmic differentiation. We have done few questions, including some exam related questions. Parametric we have done. Then we discussed about the slope tangent, right? The slope or the gradient of the tangent, and the tangent is nothing but the equation of the tangent is the differential coefficient of the equation of the curve, right? Higher order derivatives we have done d square y by dx square, and we have seen the rationale for doing it, because dx square d square y by dx square we have to calculate basically for primarily for maxima minima computation. And finally, maxima minima, we have done the derivative application from revenue function, cost function, break-even point, and profit calculation. So with that note, we would be completing. Please go through the questions once again and make sure that you study from the background material. Please try to solve the questions. Apart from the questions, go through the video once again where I have explained each of the points clearly. Once you listen to the video once again, I'm sure the entire logic will be clear. Accordingly, please practice few numericals so that you can get better grip, because differential calculus and integral calculus, in my opinion, are relatively difficult than logical reasoning and some of the other part of our curriculum. Technically speaking, these are two of the, that's why these chapters are kept towards the end, after you complete the basic algebra and logarithms and indices and all this, right? So please go through it. Limit, continuity, derivative definition, the basic formulas of the derivatives, standard formula, please remember, because once you understand differential and you are able to solve, automatically integral calculus will become easier. But I will still request you to practice more numericals, watch the video once again, and maxima minima, see the solved examples which we have covered, and you will get the rationale, get the logic, why we are having the calculation of the second degree of differential, and how we are calculating the maxima and the minima point. And revenue, cost, marginal cost, marginal revenue, average cost, average revenue. Please be very clear on these formula, because questions are coming where the testing is done to see whether you understand and you can apply economics principle with differential calculus. Okay, right. Question number 37. Let me see. Which 37? Let me just go back once again. Let me see. We stop this and just go to 37. We are already past. It's almost 4:20 now. We are supposed to stop at 4. We'll just take 37. Which 37 you are saying? I don't know. Maybe this one. Because number of questions are there, because these are from the MTP. Question number 37, 38. Let me see. Yeah, okay. This one you are saying if the total cost of producing, same, marginal cost is 5. Okay, this one I assume, question number 37. So please see once again. No, before, I don't, which one? This is, you are saying 37 again. This one you are saying y equal to 2. Question number 38. 38, that means, okay, let me move ahead. 37 is done. 38, this one you are saying. I don't understand. Once you are saying 38, again you are saying 37. I'm getting confused. Please go through the video once again, and you can see this one also we have explained well. Please try to see the equation given. We have done for minima. First you need to, maxima or minima, you need to find out the differential coefficient. And then you need to find out the value, set to value. 37. Which one I am unable to understand? This I was showing already. Total cost is given and marginal cost function is given. So we have to find out If the total cost is given, then we have to find out the marginal cost. So this is a simple one I was explaining. So marginal cost, you just differentiate the given equation. Marginal cost is nothing but the differential coefficient of the total cost. So once we have the total cost, we are doing the differentiation. So if you try to differentiate, what will you get? 1 by 3x cube plus 2x square minus 5x plus 10. You will get x cube minus becomes 3x square divided by 3 here, plus 2x square becomes 4x minus 5. So what you are getting is x square plus 4x minus 5. Now this is the marginal cost. Now the question is, this is the equation for marginal cost. Exact value of marginal cost kya hai when x is 5. So I will put x equal to 5 in this equation. This is the marginal cost equation. If I put x equal to 5, I am getting the total marginal cost. If you calculate, it comes to 40, right? So this is, I hope you were asking, I hope you have understood. So with that, we conclude. We have done a number of questions, both from the MTP as well as from the, okay. Thank you. Thank you for your confirmation that it's clear now. Thank you. Okay. Right. Okay. Yeah, you have to practice a lot. Please practice all. I'm not saying for this chapter, all chapters, kindly practice. And with the excellent support from the institute, I'm sure you will do really well. So please go through this video, because later on we will go into the next chapter I'll take up is integral calculus. So there it will be just a reverse of differential calculus, but there are one or two critical formula which you need to remember, because in our syllabus we have, you don't need to know the derivation. वो फॉर्मूला कैसे आ रहा है, that is not part of our curriculum, but what you need to go through is just make sure that you have to memorize certain formula, like the product formula I discussed, or the quotient formula you have to memorize. And once you memorize and practice, both in terms of speed, accuracy and confidence, you will develop tremendous, and that will help you for the exams. So with that, we are completing the session, and I will be stopping the slide share and hand it back to our IT team. So thanks a lot for all of you, and yeah, please go through. Next day I'll discuss more about your preparation. Please go through the study material of the institute. Please see the question bank. You have the mock test paper, model test paper, revisional test paper. Kindly download from the institute site. You will get a large number of questions. Please practice all the MCQs under exam conditions and make sure you have the right level of accuracy, right? So with that, we will conclude. Thanks a lot, and I hand it back to the IT group, IT team, please. Yeah, Board of Studies from the IT group, IT team, is anyone there? We can, yeah, we are concluding the session, sir. Okay. Thank you.